In this video, we're going to do another example from your handout. We'll do example number 3. So let's go ahead and read that and do the steps. So in a synthesis reaction, 62 grams of P4 and 4 grams of H2 react to produce pH3. So it's a synthesis reaction. That's important because it's going to help us write our equation. What mass of pH3 will be produced? So let's go ahead and write our balanced equation. So we have some P4, that's usually going to be solid, plus some H2, that's gas, is going to produce some pH3. I think it's gas. I can't 100% remember. It might be solid. No, phosphine gas. Okay. So here we have our gas here. We have solid P4, some H2, some pH3, and we're not going to fret too much about the states right now. What I care more about is the balancing because this is a stoichiometry type problem. So let's go ahead and take a look at if this is balanced or not. So we have 4 P's. We should have 4 P's here as well. So that'll be 12 H's though. So we have to put a 6 there. So 1, 6, and 4. And I believe now everything is fully balanced. And we're told we have 62 grams of the P4. And then for the H2, we have 4.00 grams of H2. And we want to know what mass of this phosphine, this pH3, is going to be produced. So mass is equal to our moles times our molar mass. So we know this is a limiting reagent type problem because we're given the mass of 2 reactants there, the P4 and the H2, and we have to choose which one to use. You can't choose the smallest one. You need to compare their mole values and see which one you'll run out first. We have a 1:6 ratio, so that'll affect which ones are limiting or excess reactant. So we know we're going to have to convert everything to moles. So let's go ahead and just prepare ourselves by finding the molar mass of everything here. So molar mass of pH3, molar mass of H2, and molar mass of P4. So for phosphorus 4, it's 30.97 times 4, and we get 123.88 grams per mole. And then for the H2, it's 2.02 grams per mole. And then for the pH3, it's going to be 30.97 plus 3.03. And we get 34.00 grams per mole. So we need to convert everything here into moles because remember, when we're finding limiting reagents and you want to do mole ratios, you need moles. You can't use mass ratios. So the mole here is going to be moles in mass over molar mass, which is going to be 62.0 grams. 62.0 grams. There's a point there. Over 123.88 grams per mole. Cross out the grams and we get 62 divided by 123.88. We get approximately 0.500484339 moles of the P4. And we're going to do the same process here. We're going to do our moles is equal to our mass over our molar mass, which is equal to our 4.00 grams over the 2.02 grams per mole. So we'll have 4 divided by 2.02. And we get approximately 1.019802 moles. So we have our moles, and we need to figure out which moles we're going to use. Are we going to use the moles of P4 or the moles of H2? A lot of us might say, well, P4 has fewer moles, so that's going to be our limiting reactant. But don't be too quick to do that. It's not necessarily the smallest number of moles. You have to compare that fairly. Look at the coefficients. They're different. The H2 is going to be used up 6 times faster. So it is possible to run out of H2 before you run out of P4, depending on how much you have there of your reactants. So we have to do one of the methods from above, either method 1, 2, or 3, to figure out what our limiting reactants is going to be. I'm going to do method 3. I'm going to determine my limiting reactant. So find LR using method 3. I'm going to choose one of the reactants and just see how much of the other reactant should be there. It doesn't matter which one I'm going to choose. I'm going to choose P4. You can choose H2 and see if you get the same result. So my ratio for reactants is 1P4 for every 6H2. Now for my P4, I have 0.50048 moles of it. How many moles of H2 should react with it? Well, I'll use my mole ratio to figure it out. So I have 0.500, so on and so forth, 48 moles of P4. Multiply by that ratio, so 6 moles of H2 for every 1 mole of P4. So I'm going to get my 0.500484339 times 6, and I get about 3.0029060 or 0.034 moles of H2. Now, look carefully here. This is what should react. Okay. Now, if we go look at our H2 over here, we have 1.98 moles. So 3 moles should react with that many moles of P4, but we don't even have that. We have less than that. We have 1.98 moles. So since 1.98, what we have, is smaller than 3.00, so on and so forth, what should react? H2 is LR. So I was clear to say what my H2 is LR, so I'm going to go up here and just put LR and then ER for the other one. Whatever one's the LR, the other one must be the ER, the excess reactant. So now I can use my limiting reactant moles, which was the 1.98 over here, and the ratio to find the moles of pH3. So let's go ahead and do that. So use LR to solve the problem. So our ratio is a 6-to-4 ratio, which is a 3-to-2 ratio. So we have 3 H2s for every 2 pH3s. And so we're going to do that. We're going to take our 1.98. I'm not putting all the digits in, but they're all still there. Moles of H2 times the 2 moles of pH3. That's our ratio for every 3 moles of H2. So I'm canceling H2s out. I'm doing basically with a 1.98. So 1.98, 0.19802 moles there times 2 divided by 3. And I get 1.32013213 moles of pH3. So that's my step 3. Use my LR to solve. And in this case, for moles, because I'm looking for moles of product. But I do need to finish the question because it's asked what mass of pH3. So I'm going to finish up the step over here. Step 4, my mass is going to be equal to my number of moles times my molar mass, which is going to be equal to the 1.32 moles. I didn't put all the digits in there, but they're still in my calculator, times 34.00 grams per mole. Cross out the moles and you're left with the grams. So times 34, and we get about 44.8845 grams, which is approximately equal to, so we need how many sig figs here? So we use the H2 in our calculation. There's 3 sig figs there. So we want to have 3 sig figs in the end. So that's going to give us 44.9 grams. That's what it's approximately is, the 3 sig figs. And then we can just do our therefore statement. So therefore, approximately 44.9 grams of pH3 are produced. And that is how we solve that problem. I used method 3 to find a limiting reactant. You can try that out as well. I challenge you to try using the H2 and saying, okay, if I have 1.98 moles of H2, how many moles of P4 should react? And then compare and see if you can get the idea that your H2 will still be the LR and your P4 will still be the ER. And you can try method 2 if you want, or method 1 as well, just see it's all consistent. Anyways, once I found my LR, I decided to use the LR, the limiting reactant, which is H2, the moles of it that you have in the question, to find the moles of the pH3. And then afterwards, once I had the moles of pH3, I used that with the molar mass of pH3 to calculate the mass of pH3 produced and make sure that it was to the proper number of sig figs, which is 3 in this case, and I wrote my therefore statement over here. In the next video, we're going to do our last type of problem, which is determining the amount of excess reactant that's left over. Because remember, when we do limiting reactants, the LR will be used up completely. So this is used up completely. There's no more after the reaction is done. But there will be some leftover product over here. Some leftover excess reactant, because this runs out and stops your reaction from happening before the excess does. And so you have to take a look at how many moles of the excess are left over. And then you can calculate how many grams of the excess are left over. So we'll take a look at that in the next video.